Hello everyone, is the Prophet Michael David, aka Aries, and today we're going to go over my third Collatz solution video, or a third explanation. Alright, real quick addressing the thumbnail. Poorly worded. I think I'm going to throw that in my description if I remember. It should say all positive integers, or even better, all whole numbers. As often, I find inspiration on the internet. So instead of trying to re-explain the Collatz conjecture, obviously, if you're watching this video, you know a bit about the Collatz conjecture. But that's the very best way I've heard anybody really explain it, and the diagrams are very good too. And so what I'm going to try to do in this video is explain my proof both ways. One's real easy. The loop way is real easy for me. But the not exploding to infinity is also logically it's easy, but I'm still trying to find a way to prove it mathematically. As I've stated before, as all good geometers, you should always split up the number line into the different base 6 lines, at least for most stuff. And so I did, and then all the highlighted ones don't get enamored with the colors, but those are basically all numbers that end the game real quick. And as you can see, the 3x plus 1 line, which is synonymous with the 4 mod 6 line, you can see that it has more special numbers on it, that it gets denser and denser with them, and it does. That is my preferred way to display the mathematics of the Collatz games, and I will address the colors and the numbers in this one. Okay, here we go. Almost all Collatz games contain these 4 types of numbers. The first type of number is the rail numbers, or the trunk numbers. Those are the gold numbers. And those are the numbers that end the game immediately. So like 4, 16, 64, they divide by 2 all the way down to 1. Now the second kind of numbers are called magic numbers, and those are the numbers that feed into the rail, aka trunk numbers. In other words, if you 3x plus 1 them, then you'll get a rail or a trunk number, and the game will end. And those are the pink and the red numbers. The third type of numbers are called progeny numbers, and those are the green and blue ones. And what those are the factors of the magic numbers, which also lie on the 3x plus 1 line, aka the 4 mod 6 line. And for every magic number that's generated, or every magic number there is on the odd number line, it generates an infinite amount of progeny that can decay down into it, because it's the magic number times X amount of 2's. And finally, the fourth type of number is what I call a prophetic number, and those are the teal numbers, and those are the numbers that obviously 3x plus 1 up to a progeny. The progeny decays down to a magic number, the magic number goes up to the rail goes to 1. And that's why in almost every, not every, but in almost every Collatz game, you have to have those 4 types of numbers, and you can highlight them in almost any Collatz game. So now with that knowledge, we're going to pivot just a bit and talk about what does the Collatz game really want? What's it trying to do? And it's trying to get into a loop. And you might say, no, that's not true. It's trying to go down to 1, but 1 is the odd number. 3x plus 1 equals 4. 4 is even, divided by 2 is 2. 2 is even, divided by 1 is 1. The Collatz game is trying to get into that loop. But half the proof, as stated earlier, is proving that's the only loop that the Collatz game can get into, and that's what I'm proving right now. All right, I've shown this graph before, but all it is I did an analysis on the 3x plus 1 line, aka the 4 mod 6 line, just to see how many 2's were in each number. And so the y-axis on the graph is just the amount of 2's that are in the number. 1 2 you can divide by 2, 2 2's you can divide by 4, 3 2's you can divide by 8, and so and so. But this effect has far-reaching consequences. You can break down the Collatz game into incremental pieces. In other words, every Collatz game is basically a connected series of you 3x plus 1, and then you divide by 2 at least once, sometimes more than once, and they form little triangles. Each one is totally unique and everything. And half the time you're going to 3x plus 1 and divide by 2 only once. That'll happen half the time. A quarter of the time you'll 3x plus 1, divide by 2, then divide by 2 again, in utero. So then you figure out all those individual triangles are all trying to fight down to or up to some number. And so what are those numbers? Well, all you have to do is set them all equal to 3x plus 1 and find out what loop they're trying to find. Okay, first one, 3x plus 1 is equal to 2x, which just means you only divide by 2 once. And as you can see, x equals -1, which means it'll never get into that loop because the Collatz game only uses positive whole numbers. All right, second, 3x plus 1 is equal to 4x, which means that you divide by 2 twice, and x equals 1, which means the only loop that series can get into is the number 1, and that is the loop that all Collatz games get into. And that is because, thirdly, if you take 3x plus 1 equals 8x, which is dividing the number by 2 3 times, then x equals 1/5, which is a fraction and not a whole number. And all Collatz game deals with whole numbers. So here's 16x, 64x, and 128x. And as you can see, they're all fractions, and therefore they cannot be loops in the Collatz game. So again, that is my Collatz conjecture solution algorithm. And I'm going to use the OG version here to show another way in how the Collatz game cannot loop in any loop except for the 4-2-1 loop. All right, this algorithm, which encompasses all Collatz games, as you can see, can only get caught in 3 different possible loops. Number 1, you have the 4-2-1 loop, which is the one that all Collatz games get caught into. But if you look closely at this algorithm, you can see, well, can't it get caught in the 4-2-5 loop as well? No, it cannot. I will explain that. And then there's one more. What about this 6 mod 6 loop? Can't it get caught in that? And no, it cannot. And I will explain all of these right now. So firstly, why can't the Collatz game get looped on this 6 mod 6 line right here? And simply put, that's because 6 mod 6 by definition is 6 is 3 times 2, and that number is just chock full of 3s and 2s. And so here's an analogy of the most insane number I can think of, but why it still cannot loop. So let's say you play the Collatz game and the first number you pick is 6 times 2 to the 500th power, which is an insane number. Way out of the bounds anyone's ever tried to play the Collatz game, way more particles than the universe, but it's a very simple Collatz game because it starts on the 6 mod 6 line and then it just loops 500 times. In other words, it bounces down the 6 mod 6 line 500 times, bounces getting smaller and smaller until it hits OG 6 mod 6, which is 6, which is even. You divide by 3, which sends you to the 3 mod 6 line. 3 is odd, times 3 plus 1 is 10, which sends you to the 4 mod 6 line. And 10 divided by 2 is 5, which sends you to the 5 mod 6 line. 5 times 3 plus 1 is 16, sends you back to the 4 mod 6 line. 16 divided by 2 is 8, 2 mod 6 line. 8 divided by 2 is 4, 4 mod 6 line. 4 divided by 2 is 2 mod 6 line. 2 divided by 1 is 1 mod 6 line, and the game's over. Now, according to my algorithm, there is only one other loop that the Collatz game can get stuck into, and that is the 4 mod 6 to 2 mod 6 to 5 mod 6 loop. And now I'll explain why that can't happen either. Okay, let's say hypothetically speaking that you pick a huge 4 mod 6 numbers, which always goes to 2 mod 6, which always goes to 5 mod 6, back to 4 mod 6, which means the 4 mod 6 number is always divisible by 4. Divide by 2, hits odd, goes back to 4 mod 6. And it happens over and over and over and over. Why can't that loop? Why can't that loop? Well, simply put, is because when you do this loop, this is x divided by 2 divided by 4 plus 3x plus 1. That's the 3x plus 1 equals 4x. And that can only be equal at one number, and that's 1. Which means any number above 1, when it does this loop, it decreases in value. Which means this loop can go on for a very long time, but not in infinity, because it always goes down until it gets to OG 5 mod 6, which is 5. And then what happens is 5 times 3 plus 1 is 16, 4 mod 6. Divided by 2 is 8, 2 mod 6. Divided by 2 is 4 mod 6. Divided by 2 is 2 mod 6. Divided by 1 is 1 mod 6, and the game ends. So that concludes my argument on why the Collatz conjecture can't end in a loop except for the 4 to 1 loop. But why can't it go to infinity? And so here are my arguments for that. Number one argument is that graph. Again, that's only on up to 4096, but as you can see, as the numbers get bigger, there are more and more numbers that have more 2's in them. Again, this is on the 3x plus 1, aka 4 mod 6 line. So at numbers close to infinity, there are going to be numbers that have almost an infinite amount of 2's. And so the higher the numbers go in this game, the more pressure there is to push the numbers lower to the fractions that all of those ones are trying to go to. My second argument, as I've stated before, is while the 3x plus 1 numbers, aka the 4 mod 6 numbers, go up linearly as they should, and the magic numbers and their progenies are exponential, logic would dictate eventually the 3x plus 1 line, the 4 mod 6 line, would be so chock full of progeny at close to infinity that the game can never get there. And lastly, that screenshot, one I've shown before, is a statistical analysis of the sum of the probabilities of the 3x plus 1 numbers, aka the 4 mod 6 numbers, having a certain amount of 2's in them. And as you can see, and I've described before, that's only over up to 4096. But even if it goes to infinity, the numbers always start at 1 and end at 1, which lays credit to the fact those numbers, either the top one or the bottom one, is kind of like what I just talked about in the previous video about how the density of the progeny at first will be almost non-existent, but once it gets big enough, they have enough wave functions that they should dominate the line and the game will end rather quickly. I don't know what rate or what number we are talking about here. It's probably much larger than 2 to the 68, but eventually all Collatz games will end very quickly at higher numbers. That's my conjecture, which isn't much of a conjecture at this point. All right, signing off. Hopefully, I prove that the Collatz conjecture can't go to infinity or get stuck in any loop except the 412 loop. As always, rule number 1, do not touch each other without another person's consent, aka do not hurt each other. And rule number 2, it's all about honesty, lies are ticked down, aka try not to lie. All right, I'll talk to you all later.